processors. The former long after Intel had released its own x386 in 1985. 101. In March 1991, AMD released the AM386, its clone of the Intel 386 processor. 48. By October of the same year it had sold 1 million units. 48. In 1993, AMD introduced the first of the AM486 family of processors, 16, which proved popular with a large number of original equipment manufacturers, including Compaq, which signed an exclusive agreement using the AM486. 8, 102, 103, the AM5x86. Another AM486-based processor, was released in November 1995, and continued AMD's success as a fast, cost-effective processor. 104. 105. Finally, in an agreement effective 1996, AMD received the rights to the microcode in Intel's x386 and x486 processor families, but not the rights to the microcode in the following generations of processors. 106, 107, K5, K6, Athlon, Duran, and Sempron. AMD's first in-house x86 processor was the K5, launched in 1996. 108. The K in its name was reference to kryptonite, the only substance known to harm comic book character Superman. This itself was a reference to Intel's hegemony over the market, i.e., an anthropomorphization of them as Superman. 109. The number 5 was a reference to the fifth generation of x86 processors. Rival Intel had previously introduced its line of fifth generation x86 processors as Pentium because the US Trademark and Patent Office had ruled that mere numbers could not be trademarked. 110. In 1996, AMD purchased Next Gen, specifically for the rights to their NX series of x86 compatible processors. AMD gave the Next Gen design team their own building, left them alone, and gave them time and money to rework the NX686. The result was the K6 processor, introduced in 1997. Although it was based on Socket 7, variants such as K6-3/450 were faster than Intel's Pentium 2, 6th generation processor. The K7 was AMD's 7th generation x86 processor, making its debut under the brand name Athlon on June 23, 1999. Unlike previous AMD processors, it could not be used on the same motherboards as Intel's due to licensing issues surrounding Intel's Slot 1 connector, and instead used a Slotter connector, referenced to the Alpha processor bus. The Duran was a lower-cost and limited version of the Athlon, 64 KB instead of 256 KB L2 cache, in a 462-pin socketed PGA, socketed, or soldered directly onto the motherboard. Sempron was released as a lower-cost Athlon XP, replacing Duran in the socketed PGA era. It has since been migrated upward to all new sockets, up to AM3. On the 9th of October, 2001, the Athlon XP was released. On the 10th of February, 2003, the Athlon XP with 512 KB L2 cache was released. 111, Athlon 64, Optron and Phenom. The K8 was a major revision of the K7 architecture, with the most notable features being the addition of a 64-bit extension to the x86 instruction set, called x86-64, AMD 64, or x64, the incorporation of an on-chip memory controller, and the implementation of an extremely high-performance point-to-point interconnect called hypertransport, as part of the Direct Connect architecture. The technology was initially launched as Optron server-oriented processor on the 22nd of April, 2003. 112. Shortly thereafter, It was incorporated into a product for desktop PCs, branded Athlon 64.113, on the 21st of April, 2005. AMD released the first dual-core Optron, an x86-based server CPU. 114. A month later, it released the Athlon 64X2, the first desktop-based dual-core processor family. 115. In May 2007, AMD abandoned the String 64 in its dual-core desktop product branding, becoming Athlon X2, downplaying the significance of 64-bit computing in its processors. Further updates involved improvements to the microarchitecture, and a shift of the target market from mainstream desktop systems to value dual-core desktop systems. In 2008, AMD started to release dual-core Sempron processors exclusively in China, branded as the Sempron 2000 series, with lower hypertransport speed and smaller L2 cache. AMD completed its dual-core product portfolio for each market segment. In September 2007, AMD released the first server Optron K10 processors, 116, followed in November with Phenom processor for desktop. K10 processors came in dual-core, triple-core, 117, and quad-core versions, with all cores on a single die. AMD released a new platform codenamed Spider, which utilized a new Phenom processor, as well as an R770 GPU and a 790GX /FX chipset from the AMD 700 chipset series. 118. However, AMD built the Spider at 65 nm, which was uncompetitive with Intel's smaller and more power-efficient 45 nm. In January 2009, AMD released a new processor line dubbed Phenom 2, a refresh of the original Phenom build using the 45 nm process. 119. AMD's new platform, codenamed Dragon, utilized the new Phenom II processor and an ATI R770 GPU from the R700 GPU family, as well as a 790GX /FX chipset from the AMD 700 chipset series. 120. The Phenom 2 came in dual-core, triple-core and quad-core variants, using the same die, with cores disabled for the triple-core and dual-core versions. The Phenom 2 resolved issues that the original Phenom had, including a low clock speed, a small L3 cache, and a cool and quiet bug that decreased performance. The Phenom 2 cost less but was not performance competitive with Intel's mid to high-range Core 2 quads. The Phenom 2 also enhanced its predecessor's memory controller, allowing it to use DDR3 in a new native socket M3. While maintaining backward compatibility with M2+, the circuit used for the Phenom, and allowing the use of the DDR2 memory that was used with the platform. In April 2010, AMD released a new Phenom 2 hexa-core, 6-core, processor codenamed Thuban. 121. This was a totally new die based on the hexa-core Istanbul Optron processor. It included AMD's turbo core technology, which allows the processor to automatically switch from 6 cores to 3 faster cores when more pure speed is needed. The Magni cores and Lisbon server parts were released in 2010. 122. The Magni cores part came in 8 to 12 cores and the Lisbon part in 4 and 6 core parts. Magni cores is focused on performance while the Lisbon part is focused on high performance per watt. Magni cores is an MCM, multi-chip module, with 2 hexa-core Istanbul Optron parts. This will use a new G34 socket for dual and quad socket processors and thus will be marketed as Optron 61XX series processors. Lisbon uses C32 socket certified for dual socket use or single socket use only and thus will be marketed as Optron 41XX processors. Both will be built on a 45 nm SOI process. Fusion becomes the AMD APU. Following AMD's 2006 acquisition of Canadian graphics company ATI Technologies, an initiative codenamed Fusion was announced to integrate a CPU and GPU together on some of AMD's microprocessors, including a built-in PCI Express link to accommodate separate PCI Express peripherals, eliminating the North Bridge chip from the motherboard. The initiative intended to move some of the processing originally done on the CPU, for example floating point unit operations, to the GPU, which is better optimized for some calculations. The Fusion was later renamed the AMD APU, Accelerated Processing Unit. 123. Llano was AMD's first APU built for laptops. Llano was the second APU released. 124, targeted at the mainstream market. 123, it incorporated a CPU and GPU on the same die, as well as North Bridge functions, and used socket FM1 with DDR3 memory. The CPU part of the processor was based on the Phenom 2 DNIC processor. AMD suffered an unexpected decrease in revenue based on production problems. 4th Llano. 125. More AMD APUs for laptops running Windows 7 and Windows 8 OS are being used commonly. These include AMD's price point APUs, the E1 and E2, and their mainstream competitors with Intel's Core i series, the Vision A series, the A standing for accelerated. These range from the lower performance of 4 chipset to the A6, A8, and A10. These all incorporate next-generation Radeon graphics cards, with the A4 utilizing the base Radeon HD chip and the rest using a Radeon R4 graphics card, with exception of the highest model A10, a 10-7300, which uses an R6 graphics card. New microarchitectures. High power, high performance Bulldozer cores. Bulldozer was AMD's microarchitecture codename for server and desktop AMD FX processors, first released on the 12th of October, 2011. This Family 15H microarchitecture is the successor to the Family 10H, K10, microarchitecture design. Bulldozer was a clean sheet design, not a development of earlier processors. 126. The core was specifically aimed at 10125 WTDP computing products. AMD claimed dramatic performance per watt efficiency improvements in high-performance computing, HPC, applications with Bulldozer cores. While hopes were high that Bulldozer would bring AMD to be performance competitive with Intel once more, most benchmarks were disappointing. In some cases the new Bulldozer products were slower than the K10 models they were built to replace. 127, 128, 129. The Pilot Driver microarchitecture was the 2012 successor to Bulldozer, increasing clock speeds and performance relative to its predecessor. 130. Pilot Driver would be released in AMD FX, APU, and Opteron product lines. 131, 132, 133, 134. Pilot Driver was subsequently followed by the Steamroller microarchitecture. In 2013, used exclusively in AMD's APUs, Steamroller focused on greater parallelism. 135, 136. In 2015, the Excavator microarchitecture replaced Pilot Driver. 137, expected to be the last microarchitecture of the Bulldozer series. 138, 139, Excavator focused on improved power efficiency. 140, low power cat cores. The Bobcat microarchitecture was revealed during a speech from AMD Executive Vice President Henry Richard in Computex 2007 and was put into production during the first quarter of 2011. 124, based on the difficulty competing in the x86 market with a single core optimized for the 10100W range. AMD had developed a simpler core with a target range of 110 watts. 141. In addition, it was believed that the core could migrate into the handheld space if the power consumption can be reduced to less than 1W. 142. Jaguar is a microarchitecture codename for Bobcat's successor, released in 2013, that is used in various apples from AMD aimed at the low-power forward/low-cost market. 143. Jaguar and its derivatives would go on to burst in the custom APUs of the PlayStation 4. 144. 145. Xbox One. 146. 147. PlayStation 4 Pro. 148. 149. 150. Xbox One S. 151. And Xbox One X. 152. 153. Jaguar would be later followed by the Puma microarchitecture in 2014. 154. ARM architecture-based designs. In 2012, AMD announced it was working on an ARM architecture products, both as a semi-custom product and server product. 155, 156, 157. The initial server product was announced as the Optrina 1100 in 2014, and 8-core Cortex-A57-based ARMv8 SoC 158, 159, and was expected to be followed by an APU incorporating a graphic core next GPU. 160. However, the Optrina 1100 was not released until 2016, with the delay attributed to adding software support. 161. The A1100 was also criticized for not having support from major vendors upon its release. 161, 162, 163. In 2014, AMD also announced the K12 custom core for release in 2016. 164, while being ARMv8 instruction set architecture compliant, the K12 is expected to be entirely custom designed targeting server embedded and semi-custom markets. While ARM architecture development continued, products based on K12 were subsequently delayed with no release planned, in preference to the development of AMD's x86-based Zen microarchitecture. 165, 166, Zen-based CPUs and APUs. Zen is a new architecture for x86-64-based Ryzen series CPUs and APUs, introduced in 2017 by AMD and built from the ground up by a team led by Jim Keller, beginning with his arrival in 2012, and taping out before his departure in September 2015. One of AMD's primary goals with Zen was an IPC increase of at least 40%. However, in February 2017, AMD announced that they had actually achieved a 52% increase. 167. Processors made on the Zen architecture are built on the 14nm FinFET node and have a renewed focus on single-core performance and HSA compatibility. 168. Previous processors from AMD were either built in the 32nm process, Bulldozer and Piledriver CPUs, or the 28nm process, Steamroller and Excavator APUs. Because of this, Zen is much more energy efficient. The Zen architecture is the first to encompass CPUs and APUs from AMD built for a single socket, Socket M4. Also new for this architecture is the implementation of simultaneous multi-threading, SMT, technology, something Intel has had for years on some of their processors with their proprietary hyper-threading implementation of SMT. This is a departure from the clustered multi-threading design introduced with bulldozer architecture. Zen also has support for DDR4 memory. AMD released the Zen-based high-end Ryzen 7 Summit Ridge series